So we're gonna use Python 3. We're gonna do the same thing we do to create REPLs, except click on Python 3, which is, I guess, the top one now. And then we will end up here. So the first thing we're gonna do is we're gonna write hello world in Python. So you're gonna write print, parentheses, hello world, no semicolon, just close it and hit run, and there we go. First Python program, done. So what do we notice about this that's different from Java? We don't have a class around everything. Python has something called free functions, which are functions that exist outside of a class. There's no semicolon on the end of the line, and there's no system.out.println. This is just print and then the string hello world. You can put semicolons in Python, you just don't need them, they don't do anything. Another difference would be if we want to have two things. In Java, I would do a plus to stick them together. In Python, that will give us a type error. So in Python, if you want multiple things printed, you just separate them with a comma. So I can do hello world, comma 5. Notice that it inserts a space between the two in our output here. So we have a hello world, we have the number 5 with that space in between. So you don't use plus to stick them together because in Java, when you add a string and an int, the result is a string with that int appended to it. But in Python, it's just a type error. It says, why are you trying to add a string and an int together? This doesn't make sense. What's the next thing we learn how to do when we're learning how to program? Variables. Let's say we want to have the string that we're printing out be hello user, and hello, then a comma, then user, but we want a user variable. In Java, I would say string user equals, but in Python, you don't need to write the type. You could just say user equals, and I'll write my name, you guys can write your own, and run that. The thing here on the right side of the equals knows that it's a string. The thing on the left is just a reference to it. So you don't need to declare the variables. You just start using them. You assign to the thing user a string object. When I go to print it and I see user, it looks at whatever it's currently referring to and it prints that. This is called dynamic typing. We're actually able to change the type of the thing it refers to. So I could say user equals 10 here, even though it's a string and then an int. This is totally allowed. It doesn't make sense to say user equals 10. It's just an example that we can do this dynamic typing thing. And I can maybe say age equals 26, hello user, comma, you are, comma, age, comma, years old. Two variables now, both of them being used. Most of the other stuff you do with int variables is going to be similar, the same. You can multiply two int variables by each other. You can do division, you can assign the results back to something. I could say first equals 20, and then second equals 15, and then say total equals first plus second, then print out the total, and I see that 35 printed here from that result. So again, variables all work together. There's nothing really crazy going on here. All right, congratulations, you're through your first week of computer science class now. These things are still both ints, 20.2 plus 15, and the result of that would be 35.2. If you want to see what the type of something is, you can print the type of it by just inserting that word type here. So what's the type of total? And I'll see class float, meaning it is of type float. If I got rid of that 0.2 and run it again, I would expect to see class int. See that thing is an int. So if you're not sure what the type is of something and you want to check it out, you can just print the type of it. Since the type isn't attached to the variable declaration, it can change. Another subtle difference would be for Boolean values. I have like a condition. We still have true and false, but they use capital letters. So capital T true and capital F false. These are still just values. They're not strings true and false. And that is about it for our primitives. There's no such thing as a char really in Python. You just have a string and then you can look at it one character at a time, but what you're really doing is looking at strings of one letter at a time. And internally, it's implemented with an array of chars, but as far as we're concerned from the outer level, you don't see that. Single quotes and double quotes don't make any difference. I can do single quotes around the strings just as well as I can do double quotes, and both of them will work just fine. The only reason you might want one over the other is if you had one of them inside of your string. So if I wanted to print like it's a nice day, I could say it's with that apostrophe there, it's a nice day. Since this is a single quote inside of a double quoted string, it's fine. If I surrounded this string with single quotes though, it's a nice day won't work anymore because this single quote matches that single quote. So if you want a single quote inside of your string, use double quotes on the outside. If you want a double quote inside of your string, so when I right here, he says hi, I put the hi in double quotes because there's single quotes around the whole string that works out. It's just why you might want to use one over the other, but this isn't really a major point, so I'm going to touch on briefly. Another difference that I should call out is we don't have a plus plus or a minus minus operator in Python. So if you want to increase something by 1, you have to do plus equals 1, and you want to decrease by 1, you do minus equals 1. When you understand more about how the semantics of this language works, it makes sense why they don't have those operators. We also don't have the same kind of for loops we use in Java or C where we say I equals 0, I is less than something, plus plus I, or minus minus I. So we just don't need it that often anyway. Let's move on to if statements. This is where things will start to get a little more complicated. Up till now, I think this is all pretty obvious. The no types on things might look a little funny. It's easy, but if you're really used to the static typing, we do have explicitly declared things, and the dynamic typing model can be a little confusing. So now let's talk about if statements. Let's say I want to do something if their age is over 18. Java style, you have if, you have your condition in parentheses, and then you have your braces like this, right? And then you have your loop body inside of the braces. In Python, we don't have braces, and we don't put parentheses around our condition. You can put parentheses, but you don't have to. So if I said if age is over 18, that's the same, and then I say you can vote. The question becomes, how does it know what's inside of the if and what's outside of the if there's no braces around it? It uses the indentation to figure it out. So when I've been on you guys about indent your code, indent your code, indent your code, it's because of things like this. It actually does matter in this language. It doesn't use braces to figure out the end. So the colon, this tells it that we're about to start an if, and then it does everything that's indented under that if conditionally. So if I change my age to 13 here, you can vote won't be printed, but the end will still be printed because the end is not inside the if. If I bring that the end up here, it still gets printed, but if I indent it, now it's considered to be part of the if and it's not printed anymore. The indentation is what decides what belongs to what. So now we have prints, we have variables, we have an if. After we did if, like what's the next logical question? Else. We have an if, how do we handle the other case? It's just else and then a colon. So if condition do something, else something else. So here I'm going to print you can't vote. Oops. I'll use double quotes around this because I want a single quote inside my string. You can't vote. And I'll stick back in that ends line. So here we are getting started with Python. We have our if, we have our else. What's the next thing we want after if and else? Else if. You might think it's just going to be written as else if and then another condition, so age is greater than 16. Python actually has a separate keyword for else if, which is elif. So I'll say if the age is greater than 16, you can vote soon, else you can't vote. So I can run this within different inputs. 13 gets you can't vote yet. 17 is going to get you can vote soon. I guess greater than or equal to 18 is really what I want. You can vote if, else, and obviously you can have a bunch of else ifs, and the same kind of thing happens where you start at the top, you check it, and you work your way down, down, and down, and down until you find one that meets the requirement, and then you are good to go. We're going to look at while loops next. Let's just do a counting while loop to begin with. This isn't something you're going to do too frequently, but for the sake of example, we'll do a counting loop in a while. So I'll come up here. One thing to shout out, if you want to comment in Python, it starts with a pound or a hash. You can keep this. I'm just going to delete what I have so far, but you can keep it all. This is just so that what's on the board stays clearer. But please, don't delete it or create a new REPL if you want, which is easier because you don't have to write class main post out of streetcars everywhere. You can just open up a new REPL. So let's do a counting while loop. I want to start my I as 0, so I'm going to say I equals 0. Then I'm going to have a condition. So let's say I want to count to 10. So you have a while and then a condition. So we'll say while I is less than 10 and then a colon. I said I don't have plus plus, so I can't do I plus plus. I have to do I plus equals 1, and then I get the right output. So both of these lines are contained within the while because they're indented. So I'll put another the end. How much of this you want to copy down really depends on your understanding of it. If you understand at the end and thanks for coming, like if you get what that's going to do, you don't have to copy it. I'm just trying to show you like what is and is not in the while. That extra space there is just to make it easier to look at. It doesn't affect what's contained by the while or not. I mean the space on line 5 that I have. So if I delete line 5 and make it like that, still only these two are contained by the while because those are the ones that are indented. You would do this. There's this thing called end. You can do end equals new line. This is implicitly what happens. There's a thing called end that gets passed here, and that implicitly puts a new line there. If you want to end with something else, like if you want to end with 3 new lines, you can do that. Or if you want to end with no new lines, you just say end equals empty string. So if you don't want to print that extra new line, yeah, you can do end equals empty string. If I wanted to write a counting down loop, I can flip this around. I could say I equals 10 while I is greater than 0, print I, and then I minus equals 1. So now I have these two loops running one after another. 0, 1, 2, 3, 4, 5, 7, 8, 9, and then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So now you have a pair of loops on the screen. If you unexpectedly indent, like let's say this print was just indented for no reason, the last one, I'm going to get an error there. It says indentation error, unexpected indent. So if you just have your spaces all over the place, your code's not going to work. So I'm going to erase this again. If you want to keep it, you want to open a new REPL, whatever. We're going to write our hello user program where we ask the user for their name and then we print hello back to them. Name equals, this is one important difference between Python 2 and 3. In Python 3, we're going to use this input function and we will put in quotes the prompts we want to print. So enter your name and then we can say print hello name. Unlike many languages, Python has a function input which you can pass it a string to use to print the prompt, and then it will also read in a variable. So you could say input empty parentheses to not print any prompt, but you don't have to do this 2 separate steps. Like you don't have to do print, enter your name, and then input on the next line, as we do like system.out.println something, and then keyboard.nextInt to read from a scanner, or keyboard.next to read from a scanner. And so this will return you a string of whatever the input is. So now we have hello name. Let's say we want to add an age here. So say age equals input, enter your age. And I could say, hello name, you are age years old. Input is always going to return a string of whatever the user enters. So age on this line, when I say 26, it's not really 26, it's 26. It's the string 26. So if I were to try to do something like age plus equals 1, I get a type error, 262, whatever. Must be string not int. So I'm trying to do a string and an int and put a plus there. Like I'm trying to do plus equals 1 onto a string, which in Java would work fine. It would just append the number 1 to the back of the string, and I would end up with 26, 1. But But if you want to convert the input that they enter to a different type, then you surround it with the type you want. So I would say int input, and then at the end of that line, I put another parenthesis. So that'll read whatever the user says, convert it to an int, and then store the result. So now I see that 27 because that age plus 1 is adding 1 to the int. So let's do it this way because age should be read as an int. If you are on Code Academy, anything that uses Python 2, instead of input, you want to use this function raw input. The function input exists in Python 2, but it does a worse thing when like people can enter their name and instead they can delete everything on your file system. It's a huge security concern. It does something called eval, where it takes whatever they enter and it tries to execute it as if it were code. If I enter 26, it evaluates it and sees this is an int, because 26 in Python code is still 26. But if I enter create a new shell and do delete everything, then it'll be like, here's some Python code that says delete everything, let's evaluate it. Yeah, so don't do that. In Python 3, you use input, in Python 2, you use raw input. So now we have user input for strings. If we want to read it as a float, meaning I can enter things like 26.5, I surround it with float. We call these doubles in Java, but double is short for double precision float, which just means a float that can hold more values than just a float. So now we're reading in something, converting it to a float, and we're printing that out. So functions in Python follow this dynamic typing principle where you don't have to say the return type. Let's go rewind to our Java days where we had to write a squared function, a function that took an int and returned that number squared. Public static int squared int num. Okay, so here we go. Brace return num times num. In Python, instead of public static int or public static type, you write def squared. And because we don't have types on things, we just put the name of our parameter, so num, and then return num times num. So still don't have a semicolon. I still end my line, the squared line, with a colon. So every time we have these things that are blocks, anytime you would have had braces in Java or in whatever language you're coming from, we're going to use colons instead. If, while, class, functions as well. The colon says we start the block. And instead of using a closing brace to close the block, we just unindent. We're at the bottom of wherever we want to be. Let's say we wanted to write a print squared function like this. You would still use def. So even if it doesn't return anything, implicitly returns this thing called none, but if your function doesn't have a return explicitly, you still use def. Let's combine a few things here. Let's read in a number from the user. So we'll say n equals int of input, enter a number, colon, and then I will get the squared number as squared n, and then print out that value. So the user's going to enter something. It's going to go into this variable n. We're going to pass it to the squared function. So num will be whatever the user entered. In our case, it's 24. Then we'll return 24 times 24. That thing comes out of this function and goes into this sq variable. And then we print the sq variable out. If I wanted to stretch this function to multiple lines, I can still do that. I can say result equals num times num, and result. And we get 144, which is 12 squared, of course. Something you might have noticed I've done a couple times is if you have something that's supposed to be multiple words. So for example, if we had our cost per bagel variable, in Python, the convention, or the more widely accepted, the right way to write it is underscores. So cost per bagel, like that. Underscores for variable names and function names. It might look weird at first, but it is just the way Python gets done. So let's do for loops, and then we'll wrap back around and do the summation function. Let's talk about for loops. So we've covered for each loops now. For each loops are the only type of for loop that exists in Python. The C-style for loop where you initialize an I to 0 and then some condition and then whatever, like all that, we just don't have that. You can get similar effects using for each loops, but the for each is just a way to do things in Python. Let's say I have some string name equals Ryan and I want to iterate over the characters of a string. The for syntax in Python is for C, where C is just the name we're picking here. It's like it was in Java when we did the for C in string. So for C in name, print C. And if I want to add things to it, I can do that. That'll print a dash in front of it. So for each character in the name, again, you want to insert in your head the word each here. It's not actually in the code, but it's there conceptually. And that's how you look at each character of a string. If we want to look at a range of values, if we want to get something where we have 0, then 1, then 2, then 3, then 4, we have this thing that gives us that set called range. So I can do for I in range 10, print I, and this will give us all those values there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's still an exclusive upper bound. If you want to change your starting point, you can do that with another argument to it, but more often than not, you're just going to say for I in range 10. Even if you just want to do something 10 times, this is how you do it, whether you're printing the thing or not. If I want to print hey here and get 10 hays printed out, I can do it that way. So we'll have I set to 0, then to 1, then to 2, then to 3, then to 4. I want you to think of this as the for each loops though. I don't want you to try to think of that for I in range as being equivalent to I equals 0, I is less than 10, plus I, because it's not really. It's more like if you had an array that was set to 0, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, and you were doing for each element in that array. It's more efficient than that, but that's the idea that we're looking at here. So we don't have a main method here, our main function, like we do in Java. We don't have a main class. But by convention, usually what you do is you put things inside of a main. So you would say def main, and then indent everything else. And then at the very bottom of your file, you would call the main. You don't have to do this. So if I had other code above this, if I wanted to do the if-else in a separate function, I could do that. But otherwise, it's going to start at the top of the file and work its way down. If I deleted that call to main down there, the main won't just run. Because again, main is not a special word to Python like it is to Java. It's just a convention. I could call this whatever I wanted as long as I call that function at the end. If you have for C in name, you're printing C here, you should get the letter. Here I'm saying for I in this range 10, print hey, but if I did I comma hey, I would see the numbers printed out as well. If I say for I in range 10, it's going to run the loop 10 times with I being 0 through 9. It'll be 0, then it'll be 1, then it'll be 2. Similarly to if you did I equals 0, I is less than 10, plus I, you get that same kind of thing, the same effect here. So let's look at summation function now. So we're going to do def summation, let's call it up to some number, and I want the sum of all the numbers from 0 to that number, exclusive, let's say. If I say summation of 5, I want 0 plus 1 plus 2 plus 3 plus 4, not the 5 itself. Total equals 0, and then for I in range num, total plus equals I. And then at the bottom of my main, I can print out what the summation is. I can say like the sum of 0 to 5, or sum of 0 through 4 equals the summation of 5. Oh, because then return the total. Whoops. So sum of 0 through 4 equals 10. If you want to include the upper bound, then yeah, you would do num plus 1. So I wrote sum of 0 through 4 here, and then I wrote 5. Yeah, the range will stop there. If you wanted to do the range including num, you would do range of num plus 1, because it's always going to exclude the upper bound. Like we have 10 here, we have 0 through 9 here. So list is like an array. It's more of something called a dynamic array, meaning it can change size when you tell it to. So with arrays, what we've done in Java is we've either created them initialized with values, or we've created them with a set size and then filled in the values later. So I'm going to say nums equals. Now instead of using braces like I do in Java to initialize the values, I use brackets, square brackets. So nums equals 7. Now I can print out the entire array, which we can't do in Java, by just saying print nums, and I see the whole thing get printed there. I can print out a specific element by just saying nums 1, so that was going to print 3, right? Yeah, so it's going to print that 3 out, so I run that. I get 3 printed. 0 is going to print that 7. If I want to print out all of the elements, we use a for each loop. So I do for e in nums, print e, and I get each element on its own line. If I wanted to print each element squared, I could do that, and we each one of those numbers squared. We're using it with a list we created this time. All the different things lists give us that arrays don't. The first thing I want to do is I want to write the contains function. Remember that true and false are capitalized, so we'll have a capital T true and a capital F false if we want to do those. See if you can write the contains function again. That takes a list and an element, returns true if the list contains the element. Don't use list as a variable name, but that's what I want you to do. So if I did something like, I'll leave this down here for reference. If I had this print nums here, if I change it to print contains nums and 3, that should be true. And if I said print contains nums and 100, that would be false. I'm getting errors showing up there because those functions don't exist. So take a couple minutes, see if you can figure out how to do this on your own. To start it off, we're going to have a def contains here, and then we're going to write the two things we're taking. So we're going to have our haystack, and we're going to have the needle. So again, we're looking for the needle and the haystack. I don't have to write the types in either of them because Python is all dynamically typed. And then we end that line with a colon. We're going to have a for loop where we look at each character in the haystack. So I can do that as for e in haystack colon. Then the question is what happens inside of there. Once we're inside of this for loop, we're just going to check if the needle is equal to the current element. If it is, we return true. And then at the bottom of the function, which is going to be in line with the for, return false. So the indentation here might look a little funky. We have to be lined up with this for to come afterwards. So if needle equals e, return true. And then we are back 2 indentation layers, because we want to be at the top level of this function, we return false. Meaning we got to the bottom of that function and we didn't find what we were looking for. And we've got true and we've got false as we expect to be returned. I want to touch on one of the big advantages of dynamic typing is that you just take things and you just use them. So this works with a list of ints, but that's just because we gave it a list of ints. If I had another thing down here, which was called words, a list of words here, so ABC, I'll just put my name and I'll say hello. I can call this contains function with this, contains words Ryan, and it'll still work. That's what that true is right there. So this can take any list of any type. As long as needle is the same type as that, it'll work if they're equality comparable. So equals equals works with strings in Python. It works with whatever objects say they support equality. You don't have to use dot equals. Works with floats, works with strings, works with ints, works with everything. And that is why dynamic typing is so great. It's not because I'm saying this is going to take ints and it'll just figure out that they're ints later. It'll use whatever you give it that works. This is something called duck typing. It comes from this saying, if it walks like a duck, looks like a duck, and quacks like a duck, then I call that bird a duck. So it just tries to use it in a certain way. If it works, it works. I want to show some of the more flexible things we can do with lists now. Things that we can't do with Java arrays. Things that might work in Java with other things. First of all, let me show something we can do in Java, which is how to get the length of a list. And that is simply you say length of list like that, and that'll give you the number of elements in it. Length is a function that takes a list, and it gives you the number of elements in the list. Or it could take a string and give you the length of the string. So one thing that I like about Python that you don't really get in Java is this uniform syntax, that things tend to be a lot more the same. Like, how do you get the length of an array? You do dot length. If you have a string in Java, you do dot length parentheses. If you forget those parentheses or you use them when you're not supposed to, you cannot find symbol. Index, maybe? That'll be the first index of the thing. You can also ask for the last element, index from the back instead of the front, using negative indexing. So if I want the last element of a list, I say -1. That'll give me 6. And if I say -2, that'll give me 5. And if I say -3, that'll give me 3. So negative starts counting from the back, but it doesn't use 0 indexing to start from the back. The reason for that is 0 and -0 are equivalent values. So if I said index of -0, it's the same as saying index 0. So there's no way to distinguish between those two. So negative indexes from the back of the list. I talked about how they can grow, but I didn't really say what that means or how we use that. If I want to stick something on the back of this, it's clearly a 4-element list. I use .append and then whatever I want to shove back there. So I can say 10, that list has a 10 on the back of it. Then if I want to insert 100 on the back, I do that again, get 100 on the back of it. And the length of it is changing every step of the way. Now it has 6 elements in it. If you were to do this in Java, if you wanted something growable, you would use something called an array list, which is a thing that will handle this for you. But in Java, like the built-in array type, yeah, you'd have to allocate a new array, copy everything over, and then add the 1 element to the back. You just have to increase the size by 1. Right, you really, in like real life Java, you rarely use raw arrays, but the concept and the syntax are a lot clearer. So let's say I want to write that program that reads in the homework grades and then computes the average of them. I can ask the user how many they're going to enter first. So I'll say num grades equals input how many grades question mark. Then I'll create a list grades. I'll set it equal to empty for I in range num grades. So this means I want to do this loop num grades times. Good point. Yes, thank you. Int input to convert it to an int first. What I want to do here, I want to read a grade from the user as an int and then store it. So I'll say int input enter a grade colon, and I'm going to store that at the back of grades. But I don't have to use grades I here. I could just say grades.append and stick that there. Let me split that up into 2 lines to make it a little clearer first. So I'll say grade equals there, and then I'll do grades.append grade. Then if I print the grades here, I'll get them all printed out. So I say 2 grades, 148, and I get those at the end. So the line 2 creates that empty list, grades with nothing in it, and then we're just appending 1 grade at a time. Read in 1 from the user, stick it at the back of that list. Come back around the loop again. Read in 1 from the user, stick it on the back of that list. Read in 1 again. I want to get the average of it. Python actually already has a thing called sum, which can do that summation for us, so I don't have to write that manually. I can just say sum of grades. If I run this, again, example, I'll write 2, 148. I expect the sum to be 148. If I want the average, it's going to be the sum of the grades divided by the number of grades, which is just the length of grades. So clearly that's what average is. But I can define an average function as well and say def average at the top here, nums, and then say return the sum of nums divided by the length of nums, and then get the average of the grades, like that. One thing that those of you that are paying really close attention might notice is I divided 2 ints up top, but I got a float back as the result. And that is one thing where Python stands out. Most languages don't do that. If you divide 2 ints in Python 3, the result that you get out will be a float. It won't be another int. If you want to divide 2 ints and get another int back, you use this / Lord division operator. How many grades? 3. I got 68 there because I used / for that floor division. But that's sort of a minor point. Because with dynamic typing, you don't have to worry about it as much because you're not saying like this returns an int and it actually doesn't. You're just saying this is a function. There's a lot of other things you can do with lists. Appending to lists is something that once you kind of have it, it's very hard to live without it. Trying to like allocate the list size first and put things into it, it just seems like a crutch. Just a rough way to go about it when you can do appending. There's way better ways to write everything up here. I can write contains in 1 line. If I want to write contains, I have my haystack and my needle. What I really want to know is, does any element equal needle for each element in the haystack? That's it. That's real Python code. This is like functional style programming. Any E equals needle for each element in the haystack. Functional programming is about this kind of thing. It's about defining the what it is, and not how you figure it out. It's a lot more expressive, in my opinion, for many, many problems, this being one of them. These are the kind of things I want to do with you guys as we go forward. These are the kind of things that I wish I could talk about in class. I just don't have the time. If I wanted to write the body of the contains in Java, it would be like arrays.stream_nums.anyMatch e arrow e equals needle, and then like return that. This style of programming is easier to understand in Python first with the Python syntax, and then translate the idea to Java. Dynamic typing, functional programming. So all of you that are here, I cannot overstate enough how much it is worth your time to be learning a second language. And clearly you guys are all realize that it's valuable, but it is so much more than you might realize. Because learning a second language helps you understand your first language way better. That's all I have to talk about today. Again, thank you all for coming. Have a great weekend.